Okay, so first of all, my apologies. Family emergency. Um, I have a aunt who is really sick with cancer, and she's not doing well. So they called the family to come in. So I don't know what that means, except my mama called me and told me to come, so I came. Um, so I'm on page 406 of your Springboard book. I'm going to walk you through these notes. You should take these same notes in your book as I'm going through them with you. Um, that way, you'll have them and you'll be writing it, and then maybe it'll help you learn. Okay, so this problem asks us to take this given function right here and to graph its inverse. So remind yourself that to graph an inverse, we need some points. We take those points, we switch the x and y values, run over here to this table where I switch the x and y values, and I created new points. I plotted each one of those new points. There's 8, -2, and there's 8, +2. There's 5, -1, 5, +1, and 4, 0. And I have an inverse function. What I'm about to say next is often only partially heard, so be very, very careful with this information because it, it can be confusing because you don't hear me completely. What I'm about to say is that every function, and this is a function, every function will have an inverse. It's not a question of, does this function have an inverse? Does that function have an inverse? Yes, the answer is always yes. Every function will have an inverse. But will that inverse always be a function? And you can see right here the answer to this question is no. This inverse right here is not a function because it fails the vertical line test. So when I say every function has an inverse, but not all inverses are functions, that's what you need. That's what we're curious about. That's the question that you need to ask. So there is a shortcut to figuring out whether or not the inverse of any function will be a function. And that shortcut is called the horizontal line test. Okay, so the horizontal line test, it's a shortcut that we use to figure out if a function that we are given, whether or not the inverse of that function will be a function. So you draw a horizontal line through this thing right here. You see it fails the horizontal line test. That means simply that this inverse will not be a function. The question part C here is what I changed the word. What test of the graph of the function can you use? And it's called the horizontal line test. Okay, this is just for a review. They ask us to write the domain and range of the inverse relation. I wrote the domain and range of both. Okay, the domain of all quadratics is all real numbers. This is an interval notation. This is inequality notation. There's not an inequality symbol. The Springboard book sometimes uses less than or equal to signs with the infinity symbol. And I just, in all my years of mathematics courses, and I've had a bunch of them, uh, I've never seen that used in any other course. So I think that's something that Springboard just did. And this is set notation. X with the bar such that X is an element of the reals. That's a curvy E. That's what says the element of the reals. The range of the given function was all Y values starting at 4 and going toward infinity. So starting at 4, use the bracket. Inequality is Y is less than 4. Set notation. The Y values such that Y is an element of the reals and Y is greater than or equal to 4. Okay, of course, remember that for inverse functions, whatever the domain of the given function is, that domain will become the range of the inverse function. So everything right from here to here just switched. Okay, we're going to jump over, skip a page, and then we go to this one right here. This equation, x squared plus 4, that is the equation for this graph, right? The parent function shifted up 4. This is x squared plus 4. So algebraically, how would you find, no, that's not it. I'm getting ahead of myself. So what could we do to that function, the g function, to make sure that its inverse is a function? Well, we can restrict the domain. Okay, so we restrict the domain. This says we're only going to graph half of the parabola. As long as we only graph half of the parabola, then it passes the horizontal line test. If it passes the horizontal line test, that means that the inverse will pass the vertical line test. So we could restrict the domain, and here's how we would do it. We say graph this function just for these x values, the x values that are less than or equal to 0. That means the x values that are on the left-hand side. So when we graph this the inverse of this function with the restricted domain, we only get this half, and now we have a function. You could restrict it to the other half of the graph, the half of the graph that's on the positive side, so just positive x values, and if we did, then the inverse would look like that, and this inverse would be a function. Okay, so on the first example right here, oh no, I didn't do it. Oh, here it is, down here. So if I take this function right here and I find the inverse algebraically, okay, that there's nothing new. We've been finding the inverse for lots of time. We've even found the inverse for these already before for quadratics. We rewrite the equation with the y. We switch the x and y. Then we get the y by itself. Subtract 4 from both sides. I have y squared equals x minus 4. I have to take the square root of both sides to get the y by itself, and that leaves me plus or minus the square root of x minus 4. So this branch right here is the graph of x minus 4, positive, the positive square root. This branch down here would be the negative. So what I'm saying right here is this was added in, okay? This was added in after I worked this example. If I just gave you this function and asked you to find the inverse would be plus or minus x. But if I gave you a restriction for that quadratic, I said, okay, this is saying, okay, don't graph the whole thing. I'm only graphing this portion of it right here. Then that means that I would only answer the negative square root portion. This is the negative part down here, the part that has negative y's. If I had reversed that and said restrict it for x is greater than or equal to 0, then the positive square root of x would have been all I answered. That's what I'm saying down here. If I'd restricted it this way, then this part right here would have been my answer. No restriction, both the positive and the negative branches right here would be the answer. With the restriction for x is negative, this would be my answer. The restriction for x is positive, this would be my answer. Then on this page, I just work several examples. Switch the x and y, solve for y. A couple of crazy things happen. I'm not sure how much time I have. Where is the crazy thing that I do with the negative? Oh, right here. So in this problem, I divide both sides by a negative. Notice that I've switched this. Okay, why? Because if I take this problem right here, this positive x is negative 2, and I divide the whole thing by a negative 1, the x becomes negative and the 2 becomes positive. So I just wrote it with the minus second. Cube both sides, subtract 14. I did the same thing again. I divided both sides right here by a negative 7. If you divide by a negative 7, that means this 14 becomes positive, and this thing right here becomes negative, and then the 7 is no longer negative because I switched this. So just a little algebra that you need to be aware of. Okay, I'm probably going to stop the video right now and then go show you about these two problems. I don't think I'm going to do both of them, but you are going to need the graphing calculator for this. Okay, I'm going to share this. I'm going to stop it, upload it to YouTube, and happy solving. I think your homework is on page 414, 413, 414. Look on It's Learning.